Contact right. Okay, engine stop. Houston, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
It's been a while since my last video demonstrating the analog to digital converter that I put together for the Asteroids Deluxe Lunar Lander Multigame kit. And with my first prototype, it worked, but it had a few issues that I had to work out, and decided it was time, since the new multi-control panel and control panel overlay is getting ready to come out. There's also a couple people developing this same analog to digital converter based off of basically the same schematic that I based mine off of. So I decided to jump back in and make another prototype, a little simpler, something more closer to what might actually be the final product, and hopefully I can give those guys a little bit of insight and information and help while they're developing their prototype. So what I did was I basically put away my original prototype and can't find it. So I just went ahead. It'll turn up one day. I know I put it somewhere where I know where it was, but you know how it is. So I went ahead and put another one together. This one here uses a smaller, about half the size circuit board, a prototype board you can buy at Radio Shack. And this time I put the converter chip on a socket so I can pull it in and out. And basically I left off the diodes, the LEDs that I had, which was basically a visual reference, so I knew that the converter was working. But since it's proven and they're not needed, this prototype doesn't have them. So right now I got it hooked up to the multigame, and of course I got 3 wire connecting up to the original Lunar Lander thruster. So now let's turn it on and put it in test mode and get some readings. Okay, here's the test screen for the Asteroids Multigame, and as you can see right here, it has the numbers for the thruster. And since I have it set up for the digital thrust input, right now it's being controlled by the original Lunar Lander thruster. In the down position I'm getting 65. Now this number represents, it's not just a regular number, it's what you call a hexadecimal. In other words, it doesn't count like 1, 2, 3, 4, 5, 6, 7. It has the numbers, but it also has numbers and letters. As you can see, I'll run it up real slowly. Like I say, it's starting out at 65, and as I go up, it starts counting. See there where it went to 6A, and 6B, 6C, D, E, F, then goes to 70, 71, 73, 4, 5, 6, 7, 8, 9, then it goes to 7A, B, C, and on. That's a hexadecimal. So this is full throttle. Right now with full thruster, I'm getting 9A. And when I let it go back to low, I'm getting 66. It drops down to 65 sometimes, but it varies just a little bit. But actually it's very stable. So basically I'm going from 65, 66 up to 9A. And if I press it real hard and go beyond the compress that rubber stopper, I can actually get it to go up to 9C or D. But just with hardly no pressure at all, full throttle is 9A, and low is basically 60, I say 65. So 65 is the low, and 9A I'd say is the high. That's the readings I'm getting. What I'd be interested in knowing what anybody else would be getting. I'm not sure if the original Lunar Lander test screen has this hexadecimal readout. I've never actually seen the Lunar Lander test screen. If it does have this hexadecimal readout, I sure would love to know what the numbers are for an original Lunar Lander game. So if anybody can do that, also anybody else that's made their own analog to digital converter and has hooked it up, as I have, with this original thruster and to an multi-game, I'd like to know, basically what numbers are you getting, so we can kind of compare our notes and see if we need to make any changes. Alright, now let's go into the game mode. Take it out of test mode. And of course it goes into the diagnostic. And let's put it on a game of Lunar Lander. Okay, here we are, Lunar Lander on the multi-game. Let's press the start button. And now, if I open the throttle up, see, I seem to have full range of thrust. But here's the controller. I have to move it that far before I can get any thrust. So I'm not sure if I'm getting the right amount of travel for the thrust that I'm supposed to be getting. That's all the way down. That's where it starts. Okay, it's all the way down. Right there is where the thrust starts. But it goes to full thrust. Does this look correct? Maybe I get a little better picture. Looks like I'm getting the full thrust. My concern is if I'm getting the correct amount of travel on the thruster. So maybe somebody can look at their Lunar Lander and tell me, or maybe even take some video of how the thruster, the travel on the thruster is working. Well, for now, the second prototype of the AD converter for the Asteroids Multigame seems to be performing pretty well. I just need to do a comparison between the amount of throw that the thruster has for an original Lunar Lander as compared to what I have here to see if it's the same. If not, we may have to look into adding a resistor in a series with the pot, one side or the other, like it did on my first one. This one here seems to be more stable. I think that may be because I left out the LEDs this time. That may have been causing some instability in the output of the chip since it's tied into the output. And also I haven't had a problem with it not, the AD chip not starting when it's powered up. So I may not even need to add the active low reset circuit. But in case I do, I'll do some more testing. I think I've done a little research in it, and I believe it can be done by just adding an electrolytic capacitor in the reset circuit. Maybe even have to add a resistor and a capacitor, but I'll look into that if it's necessary. And for now, until I have something else to share, that's about it.